Thank you, Olga. Yeah, my name is Eduard Lebedyuk. I currently work as a cloud engineer at InterSystems, and I help organize, architect, and deliver InterSystems Iris-based workloads in a cloud. Previously, I worked as a sales engineer and helped with the same for our clients. Now I do the same thing internally. So that's why I'm giving this talk. You have an opportunity to ask questions by typing them into a chat. Also, I will send this presentation into the chat too, and we will send it after the meeting because there are a lot of links. So let's get started. Yeah. And today on the agenda, we'll talk about stateful and stateless workloads and cloud specifics of networking, mirroring, backups, and monitoring. So let's get started. When we deploy Iris into the cloud, we found that there are two base patterns, architectures, if you will, stateful and stateless. If you need Iris to always be up to process workloads as they are coming, that would be a stateful architecture. Usually you use virtual machines, and actually it's pretty similar to what you might find as an Iris installation on premises. There are some adjustments for cloud, certainly, especially networking, or you also might want to move some of the functions to the cloud, such as queues, or for example, some triggers. You can make them as lambdas, but still the base Iris infrastructure, base Iris architecture is fairly recognizable, which we will see in a few slides. Another way to deploy Iris is stateless. If you want Iris to run only when an event happens, where a file is uploaded or a message arrives in a queue, or maybe start Iris once a day to build a app, or start Iris once an hour to process the backlog, something like that. You know, when Iris is not running, it might be in that case stateless and container-based. It's not actually a requirement. You can totally have a VM-based stateless architecture, and your stateful architecture also might be container-based. But in this example, I want this kind of separation. We found this kind of separation useful, especially depending on the limitations. So stateless architecture is naturally more limited, which we will discuss. But there are also some considerable advantages. So let's start with the stateful. And here is the sample. It's actually not a reference architecture, but one of the architectures for one of our cloud public offers. And you see the familiar site. So we have two mirror members, which are in separate subnets, Arbiter in yet another subnet, two web gateways, one for each mirror member. We offload the authentication to the cloud provider authentication module. In Amazon, it will be Amazon Cognita. We have a Bastion host to perform monitoring and management tasks, and so on and so forth. But still, this type of architecture is fairly similar. There are certain similarities to the traditional on-premises deployment, just moved into the cloud. Some parts are offloaded, such as authentication, management, backups, for example. They would be performed in a cloud-native way. But the machines, there are still EC2 virtual machines which are running in a cloud. So one of the issues our clients encounter is virtual IPs, which is a requirement for HL7 shops primarily, but really for all highly available Iris deployments. And the problem is as follows. Sync mirror members must be placed in separate subnets, usually in a hyperscaler cloud, you have the requirement that one subnet is in one availability zone. So it makes sense that you want to place mirror members in a different availability zone, so in a different subnets. Why? Because it saves you from, it gives you redundancy for AZ failure, right? If both mirror members are in the same subnet, in the same availability zone, you are only protected against iris failure. If iris shuts down for some case, yeah, the failure happens and it works fine. But if you have issues with AZ, then you have a trouble if both of your mirror members are in the same AZ. So you don't want that. You want primary and backup to be in separate subnets. On the other hand, iris mirroring requires both mirror members and virtual IP to be in the same subnet so they can reassign the virtual IP on the OS level. And naturally, these two requirements are in a direct conflict with each other since they are not satisfiable at the same time. Except for the fact that all networking in clouds in AWS, GCP, and Azure and different clouds are really software defined, right? And in this case, you can take advantage of that and resolve this issue by reassigning virtual IP, by routing virtual IP network packages to a currently correct mirror member, so to the current primary. Since it's all defined in software, that is quite possible to do. I link here an example in AWS. You can check out our clouds, but if it's not possible, you can fall back on load balancers. That will also work where you place the load balancer, and it has two targets, mirror primary and mirror backup. And that will naturally work, but there are issues. One issue is that load balancer costs extra, and second, that you have port limits. If you define load balancer and if you use load balancer, you usually, first of all, you cannot just assign like 100 ports range. You usually need to assign them one by one, which creates a lot of configuration to manage. And second of all, you have port limits. If you provision a load balancer in cloud, you cannot usually provision 10,000 ports on it. For AWS, the limit is 50 for network load balancer, for example. And 50 ports might sound like a lot, but if we are talking about TCP-based communication, HL7, health exchange, it is usually not enough. We have a lot of customers who have hundreds of ports allocated. And it's all doable with load balancers, but certainly a considerable challenge. So if you can use software-defined networking to your advantage, that is definitely a more preferable approach. Next question is backups.
We have a question in the chat from Scott.
We have a question. Can you read it for me, please?
Sure. So are you using a private LAN across mirror members within the cloud?
Yes, of course. All the traffic between mirror members is routed through AWS network, and they are not public at all. So we have, to go back here, we have web gateways, which are in public subnets, which are available publicly. But mirror members are in private subnets, and so they are only accessible through the web gateway. And if we need the ports, it's usually done via direct connect or VPN gateway or via transit gateway if our counterparty is also has a VPC in AWS. But really the mirror members usually don't have public IP assigned unless you have a really strong requirement to do that. There shouldn't really be a reason to give access to publish an IP of a primary or backup mirror member. Web gateways are can be moved to a separate hardware specifically for this purpose. Well, okay, not specifically, but that is one advantages of running web gateways separately. Okay, I hope I answered your question. So backups. Before we go into backups, the most important thing you need to remember is that you use different disks for different parts. You have operating system on one disk, you have IRIS installation on another disk, databases on yet another disk, and two disks from journals, primary and secondary locations. What else to say about disks? As a little help, especially if you have issues with disk, sometimes running out of space, and disk usually in clouds can be dynamically allocated and expanded. Well, one tip and trick which I would like to share is using the balloon files. Basically, you provision a disk and you also create an empty 1 GB or 5 GB or whatever file, which is completely empty and just taking space. The advantage of that is that, first of all, your notification system would fire a little bit earlier. If you don't have a notification system and you go into a system and it's 100% full, some operation might fail because there is no space, right? And it's very easy to remove the balloon file and restore the system. But again, of course, having a complete monitoring system is a better solution. So for cloud, we definitely recommend using external backups and backup software usually has callback scripts which you execute before backup automatically and after backup. You call the freeze action and it freezes the database and it rolls over the journal to the next file. So when you do backup, remember that the backup is true at the time of a freeze. And it would be consistent at freeze time. And after that, of course, you on the post backup callback, you need to unfreeze the system. It is enough to mirror only one mirror member, either of them, as long as they're synced, so primary or backup. If you have DR, they are not a viable target for mirroring, for backing up. They might be away for a larger time. Usually not, but definitely recommended primary or backup. There is no reason to back up both mirror members. It will double the cost of your backup solution at minimal additional gain, because usually you want to restore one mirror member with the latest backup, make it primary, and create a new backup from it. Monitoring. So you can get basic health checks by getting these two URLs, cache status CXV and mirror status CXV. I will recommend it above management portal, or maybe in addition to system management portal. They are faster and simpler to do. So they just return when you call these URLs, they just return one word, very easy to parse. Of course, if you need system management portal, you can also parse request the system management portal URL. That can be an addition. And finally, there is an API monitor API now available. Well, okay, it's been available for a few years already. And now recently it has interoperability metrics added. And also it provides a very easy support for your own custom metrics. You just need to define an implementation of metrics collection. No way around that, I'm afraid. But after that, they would be added and available at the same place. You can do metrics per namespace. You can do OS level metrics, everything you want, and they are provided in /API monitor metrics in Prometheus standard, which is an industry standard. A lot of tools can monitoring tools can consume these metrics and propagate, build detectors, and send alerts based on the metrics values. Another thing to check is the timeout on metrics collection. If you don't collect metric during that timeout, it would be a failure. So please remember that too. Okay, I think that is all I have on stateful architectures on VM deployment. If we have any questions on this part before I move to stateless architecture, which is considerably different, let's have Q&A right now if there are any questions. Okay.
Edward, I have a question.
Sure.
Speaking of stateful deployment, if I have a Docker image on Iris, can I have a stateful deployment too?
Yeah, of course. Yeah, why not? As long as you store the data and Iris is always up and about and running, it would be a stateful deployment. And even if it would be a container inside of a mirror A and a mirror B, that won't that can still be completely stateful. Yeah.
Yeah, but so what is the easiest configuration? For example, I don't have mirrors. I just want to deploy a container periodically, into any cloud provider, for example, AWS. How can I manage the cloud configuration to connect to the storage? So what is the storage in this case?
Well, on the container side, you need to define IC durable. So to use durable sys feature to store all the configuration in an external place. And after that, depending on the container orchestrator you're using, that would be different. So you mount some type of a volume. In Kubernetes, it would be storage. In ECS, it would be, well, with ECS, it would be a bit trickier because it supports only the file mounts, which you don't really want. So yeah, it would be probably.
Yeah, my quick question. So maybe even first of all, I could avoid durable sys. I mean, for example, if I have users in database, not in InterSystems database, not in sys. So I'm saying that I just need to take care about the database volume I'm connecting to from Iris container, right, on the cloud. And what are the preferable configurations? I'm looking for, maybe is there any easy to follow architecture? Maybe you have a repository that reproduces such an approach or something like that.
So yeah, if you want to, it would be either. So one of the approaches you can run an EC2 if you want to run Iris all the time. You can provision an EC2 with Docker. Another approach you can have is to use either Kubernetes or manage Kubernetes and attach a storage to a pod. And that would be also durable. If we are talking about more managed orchestrators, so where you have less options than Kubernetes, you need to check that they support block storage. They usually support mounts, but most of the time they support file mounts, and file mounts are not suitable for long-running Iris when we want to sync the database file all the time. It would be, first of all, slow, and second of all, prohibitively expensive.
And file mount, do you mean S3?
No, it's S3.
It's not
HVs also won't work, but when we talk about the mounts, we have two types of mounts. We can mount either a file system, which is a file-based storage. In AWS, it would be EFS. And we also have block storage, which is basically disks. It would be EBS in AWS, for example. And for Iris database files, you always want the block storage.
Okay, and what the stack do I use when I want to perform such a deployment? Should I use?
Regardless of which deployment you want to use, you need to use your infrastructure as code tools, which might be a Terraform. It's open top these days. I hear serverless or CloudFormation or any other tool. Define the resources you want to provision and apply the template to your account.
Terraform, Helm. Do you know if we have like a Helm template for Iris deployment with the stateful?
I think it's available in community, definitely. Some examples.
On Helm, actually the Helm marketplace, right? So I googled it, didn't find it like from scratch, but okay. So I'm asking that many questions because this becomes more like demanded, I would say. So that okay.
I definitely remember on learning we have a CloudFormation stack, which deploys Iris.
With a stateful approach, yes. So yeah, I'm just curious if we have like something very simple, very basic. I just want like this. But generally to reproduce what we have on a laptop. Yes, so I have something working on a laptop, developing with Docker, and then okay, I like it. I want to deploy it like one container instance to the cloud I want, and like with one Iris, one database. It's simple like that. So it would be great if we have some template like that to ease the deployment. So I understand that there are a lot of this could be architecture like that. That's what you expose now, but this is not my question at the moment. So I'm seeking for something that is one Iris container and stateful database that will not be destroyed. Will be mounted with every time when we republish container, for example. Yeah. So.
We can certainly never have enough examples. Hopefully,
yeah.
We'll see some more on community. And
okay.
Actually, my stateless slides they do cover in part of the questions. Okay. So let's.
Maybe there are more questions to Edward.
Yeah. Any more questions on stateful part on VMs too?
Hi, Eduard. This is Guillaume. What is cache status.txw and my mirror status? For the monitoring part, you have OpenTelemetry, that's neat, but what is the basic health checks?
Oh, yeah. So if you have system management portal, well, system management portal doesn't matter, but if you have a web gateway running, you can just add cache status 6 and you get success if Iris is running. And
that's neat. And there is nothing on the documentation about that. I was trying to look at it.
It's all documented.
No,
it's not.
The best part of documentations you can see on our roundtables.
Okay.
And mirror status, this one shows that my Iris is not part of mirror, but if it would be, it will show I have a primary or backup. So you can easily learn which Iris is primary if you need to do something only on a primary, for example.
Very cool. And quick related questions. is what is the format of this data that is available on monitoring? Yeah, it's a REST API, I suppose. Yeah. So what's
No, it's OpenTelemetry. It's something else. Yeah.
Well, yeah,
OpenTelemetry.
it's a REST API, right? Oh, yeah, here it is.
Prometheus.
It is,
Yeah, it's Prometheus.
Prometheus. Yeah. So here's an example, and yeah, it is a pairs of key value separated by white space. Some are per system, and some are per. Like you can have the same values with identifiers.
So it can easily be sourced to Prometheus and as a
And
source.
Grafana. And Grafana for metrics.
Grafana for SAM.
Yes, SAM consumes this matrix. You can deploy SAM and use that as your default monitoring tool. That is certainly a recommended approach. It uses the API monitor metrics, and you can also add your own metrics, and they would be available in SAM. Yeah.
And you say it's very easy to add your own, yes? And do we have any examples of Open Exchange or like documentation?
I don't think I have example on Open Exchange, but in documentation we definitely have an example. Yes, it is the same as the old sysmon metrics. So that is actually just a REST interface to them. So that would be a custom metric. Yeah. Any other questions?
Yeah, out of the box, does that include like basic VM metrics like CPU utilization and RAM utilization? Do you know? I'm just curious. I can off the top of my head, I can research.
I think that's when I played with SAM before, I had to add that into Prometheus. It's separate downloads, I believe.
Separate downloads from a different source, or did you make a custom metric that just included it in this metric API?
A custom, well, basically, I mean, it's a custom. I can't remember. I played with it months ago. I haven't played with it since. I need to get back into that. But you can grab, like, we're on Red Hat, so I was able to grab stuff from Red Hat. There's stuff that like dashboards you can download from Red Hat, to access that data.
Okay.
And at least, Ben, I think the first line is CPU usage.
That is only Iris usage.
Oh, that's Iris.
So that's not total CPU.
Okay.
But I mean, if you're only running Iris and you're not running language gateways and web server, it is pretty good. But you probably still want to connect to collect OS level metrics.
Yeah, Ben, I understand where you're coming from because we're having a lot of issues with drop packets. So this would be a nice way to try to figure out where the drop packets are happening. So
right, correlating it with the OS level stats.
Yes, yeah, exactly.
Okay. Sounds like a good intern project.
Sounds like a good idea for Open Exchange package.
Certainly.
Yes, it does. I'll include that in the spec for my intern project, Evgeny. Publish it after.
Amazing. Love our roundtables.
All right. So, any other questions?
That's always easier. Go ahead.
Is the cache status and the mirror status, is that available? Is that only in the new versions, or is that, how far back does that go?
I think it's available from like version 5, so it's definitely not new.
Okay.
It's very old. And you also then you can, yeah. It's even
for those who remember.
Been around quite a while. Yeah. The good part is why I use them is that you don't need to remember all the URL for management portal. It's you can just add it to root or to any application, and it will always work. Well, I mean, if Iris is up.
Nice.
Okay. So stateless now stateless architecture. It's basically event-based. When you don't want to run Iris all the time, you want to run Iris only when you have something to do. You get a new file to process, you get a new message in a queue, you want to build a report daily, you want to process a backlog hourly, really, whatever. Iris is up only when there is something to do, otherwise it's not up. Of course, it brings us great cost savings. Now, when I tell stateless, it doesn't mean that we don't have persistent state. It just means that it's not stored in Iris. So how to store states? State is stored externally and retrieved from the following places. First of all, if you have any deployment configuration, so it would be a task definition, it would be a pod definition, or basically it's a definition of the workload you have external to Iris, and Iris is created based on this definition. It's the most basic part. It's usually read-only, so Iris cannot change its own definition, and that is fairly small. It is for connection points, credentials, secrets, and stuff like that. Basically how Iris should run. Next, you have blob storage, for example, S3, where you can retrieve and write data. You can have mounts, which can be a file system mounts and block storage mounts. The difference between them is as follows. When you have a file storage mount, you work with files, and any change in a file results in the upload of this file. So it is not suitable for Iris dot, but it's suitable for individual classes. It's suitable for one at a time. Even Iris dot upload, why not? If you don't mount it, but just upload it or download it. The block storage is suitable for Iris dot files, since, well, it's block storage and it has IOPS to support that. And next difference is that when you have a block storage, it usually can only be mounted into one place, or at best, it can be mounted at maybe a dozen places at most. So you can have 2 or 3 irises actually using the same block storage. That is supported in some configurations. File storages don't have this limitation. Usually you can mount file storage at hundreds or even thousands of different places. I mean, different compute places, and run them without any problem. And of course, any integration. Iris is an integration engine, so you can integrate with any external system and send and retrieve data from it. It can also be a centralized Iris, so you can have one Iris box which is always running and which can create extra compute, which is stateless and only connects via either ECP or just defined REST API to retrieve or upload the data. So when you start this stateless Iris, you need to inject the state, and you have the following places where you can do that. First, you have zstart, which is the first thing, customizable thing, which you adjust and which we will run. You have a guarantee that before zstart is done, nothing will work on the system. So there is no race condition between zstart and production start. After that, enable production auto start, and it will start your production. And finally, you have production on start method where you can define something related to production. System default settings are very convenient place to store and retrieve the configuration. Usually we do it as follows. The system default settings are imported during container build. then they are updated in Z-start based on variable environment variables passed to a container. It's used not only for production business hosts, which can definitely and automatically use system default settings, but also from different parts of a code base. So there is no direct retrieval of environment variables. They are all retrieved through the system default settings. If you're working with health products and you're using foundation productions namespaces, you can use health share registry, which is a key value store. And yeah, you can also do the same basically by first setting this key value store to your environment variable values, and after that retrieving it from the application. Well, depending on if it's interoperability primary or if it's only health share parts. So you can run containers in many different environments. Kubernetes, managed orchestrators, and opinionated managed orchestrators. And I ranked them basically, the higher you are on this list, the more options you have. But also you need to spend more time on administrating this solution. And the lower you go, the less options you have. But also it's very easy to spin and run. And you can choose depending on your requirements. And basically, you want to choose the easiest solution, which still does everything you need to do with your container. Here are the limitations. So first of all, limits on CPU, I/O, and disk, which become very important very soon. For example, so if you're on Kubernetes, you can usually allocate whatever you want. But if you're using Fargate, AWS ECS with a Fargate backend, where you don't manage servers, you just provision containers and they are just running somewhere. So you're limited to 16 CPUs, and your ephemeral disk is limited to, I think, 200 gigs. Next are the limits of a number of replicas, and they're usually not as important. Most of the time you have limits in hundreds and thousands, and that is not a problem unless you're running a GPU intensive workload. So if you provision the containers with GPUs, right, the H100s might be in short supply everywhere. But generally, if you just CPU, you can get hundreds or thousands. Another thing to remember is when you allocate your task, there are between different cloud providers, there are different strategies on how that works. If, let's say, you ask for 100 replicas of 100 containers to run, and the cloud provider managed to provision you only 99, for example, sometimes you will be given 99, sometimes, depending on the provider, the operation fails you and you will be given 0. So that affects your strategy. You might want to scale not all at once, but by like 10, 10, 10, 10, you know, some small chunk which you're sure would be provisioned, and you repeat this chunk till you get to the number of replicas you desire. Going all in might fail because you cannot allocate like thousands of containers at the same time. So limits on container size. Some of the more opinionated orchestrators limit container size. For example, UpRunner, I think, has a limit of 5 gigs, which is very close. Use multi-stage builds. They definitely keep the container to the size to the minimum. Use container inspect tools to check the layers, and generally try to minimize the size of your container. The smaller your container, the faster it would work, and the less you will pay for storage and for time required to provision it. Parallelization. So there are two parts to it. First of all, you need to adjust your application to be able to work in parallel. Ideally, any of your containers can satisfy any of the requests which arrive, or process any workload which arrives. If you cannot, there are workarounds, mainly either session pinning or having a centralized state at a minimum at some centralized location. But again, ideally, you can scale, as soon as you can scale to 2, you can scale to N and process the request independently from each other. Another thing here to remember is that your auto-scaling strategy, you can scale based on number of requests or the number of, for example, backlog size. If you have a backlog, if, for example, you consume for a queue, you can scale based on the size of a queue. So the average number of workers per queue is some number n, which you need to calculate, right? Another way is if you're running a REST API, that would be just a number of requests per container per minute. And as long as it gets above a threshold, you provision more containers, so the average goes down, and so on. Another thing to care about is scaling to 0, and definitely recommended. You can get great cost gains if you can scale to 0. In that case, you need to use cloud native queues. You need to use async processing, and you need to think about your first request strategy. Basically, some orchestrators would scale you but would drop the request. So that really depends, right? When the first request arrives, and I mean it's HTTP, right? If it's some external queue and request arrives, you definitely have the time to scale out. But if it's an HTTP request, that's different. Not all orchestrators will be able to hold the HTTP request for you while the container is being allocated, started up, and so on and so forth. And of course, you're minimizing your startup time might be very important in this case. So that is completely different strategy to scaling to N. And you might use only one, or ideally you might use both. So you want to scale to 0, and you also want to scale from 1 to any number of replicates. Here is a sample architecture, which is, here's our goal: to start Iris only when there are files to be processed. We have some storage location, and storage location is connected to external queue, which automatically generates notifications when a new file is dropped into the blob storage. Queue length, as long as we get a positive queue length, which is above 0, we spin Iris containers based on the number of messages in the queue, retrieve data from queue, retrieve file from the blob storage, retrieve state from blob storage and configuration, process the file, and send it to the destination. So that is a simplified but fully working, actually, container-based architecture. It would scale to 0, and it will also scale to n replicas. So if someone suddenly uploads like 1 million files in the blob storage, that will work, and it would be not one Iris container, but up to it would be auto scale based on a number of containers which you define as a maximum. In this case, the scaling would be also automated. So that is what I have on stateless architecture. And if we do we have any questions?
Yes, we
because
do.
Before, okay, yeah, that's Evgeny.
Yeah, I have several questions, but maybe anyone wants to have anything else. Okay, so colleagues, please go ahead with questions in the chat or in out loud. Eduard, you mentioned system default export import feature. Could you tell more settings? System defaults, yeah. What
System default settings? Yeah, that's the feature name.
What can you export, and what is the use case? And what is how to use this? Any like hints?
I had, I think, an article on community about system default settings, but the short of it is that you have an XML file which is imported into Iris, and you have these settings, this page, which are also applied in production. So I have system default setting archive IO equals 1, for example, for all productions, for all items and all hosts. And if I go to my production, I will see that archive IO is equals 1. And if I click on setting value, you'll see my current value is 1, and the source is a system default setting. So that is system default settings. They are available as XML file during Docker build. So during Docker build, you import the file, and the settings arrive in your system. After that, you update their values from the environment variables to the setting value which you want in runtime. Does it make sense?
Makes sense.
Was the question about the use case, Evgeny? Like why?
No, it's okay. Yes, use case is clear. Question is it only for interoperability?
No. No, that is not for interoperability only. You have, let me find it. Production settings. No, not production settings. There is a call which you can use. No, not this one.
Yeah, but you opened it in interoperability section of Iris. So if that's why I think it relates to interoperability part of the solution only, right?
I'm sure you could write custom code to use them for other values, but I believe out of the box it only applies to things within interop.
They apply certainly only to interoperability hosts, but you can have a call. I was sure I wrote about it somewhere. Maybe here.
I was hoping like you can snapshot your current Iris configuration to a file. Like everything.
Yeah, here it is. Here it is.
I've been pushing for that for a decade, Evgeny.
Yeah.
What's the problem? I mean, actually,
I wish.
Anyway, so we could this file could be also a part of source control, right?
Yes.
And that would be the default settings.
And it could be deployed by package manager also.
Yes, of course.
Yeah. They're typically environment specific. So at least in our pipelines, we have system default blob for base and then a different one for test, because the connectivity endpoints for FTP and credentials and all of that stuff differ from production and non-production. So that's the big value of using system defaults, is you don't actually include the endpoints and whatnot in your production items in source control. You leave them blank in source control for the production items, and then system default fills in those blanks. And so that allows you to have environment specific endpoint settings. But they should all be versioned, but just according to, this is non-prod, or this is development, or this is production.
Yeah, this is neat. It'd be great to have like the whole system settings too. Okay, but I think maybe the combination of merge CPF and these production settings maybe could move the needle, right?
Yeah, merge CPF can do a lot.
Okay.
Jenny, we've got an internal project to try to catalog and call the export APIs for everything system configuration related. We can talk offline, but it's answer your earlier question. The challenge is that there's so many things stored in so many different places, owned by so many different aspects of the platform. There's not a holistic way today to access it, but I'm hopeful that we'll get there eventually. I'll keep pushing.
Yes, and you have like all my support too. So I mean,
yeah.
You mentioned container size.
Yes.
And just for information of everyone, there is a very good article by Guillaume Renier on community that reveals all the. I will share it now. It's in a chat. Yeah, so how you can make your images tiny. Yeah, it's some module that Guillaume introduced, and I think it uses even Python, and some techniques with Docker file, so you could make it.
Yeah, basically, yeah, this is Guillaume. Basically, it's multi-stage build. And the last part of the multi-stage build, I do not start Iris. So I look up for the build stage, take off what we call the CPF file. I'm looking for the difference between the CPF file from the builder and move all the data, all the iris data class, all the iris.dat files to the new CPF file. I took the old CPF file, I copied it to, how we call it, to the final image, and this final image never start iris to keep it slim. Because when you start iris, it's putting layers on, I don't know. When you start iris, there is some iris that the hash change.
It's solving
Go ahead, Dimitri.
architectures issues with Iris, which is because a lot of settings stored in database in Iris, and main database is IRIS or SIS, which like around 90 megabytes, and the how containers work is any changes in any file goes as a next layer, where like be it small changes like changing the password of user, which goes to this database 90 megabytes, and Docker says, okay, it's a very new file, we add it as a new in a new layer as a new file, and not only this one, also beach file, also journal files, and so on and so on, and you get like hundreds of megabytes, depends on how many changes and how many databases you change it. So that's why. So, and with this multi-stage way, we just do not move, do not keep these changes. Even like start iris and stop iris without any changes at all. It change it to logs, log it data of start, last start, or last changes in this system database. So it still appears in as a new thing. So that's, and yeah, this tool is very cool. So it helps to understand what's really happening on each layer, and by this image is so big, so we can see each file, what was changed. Even like if we delete some files, it also helps understand how to write Docker file optimally, because each line, if each copy, if each run is a different layer in the Docker image. And if we do something heavy in one run, but we need to delete some files, temporary files, and we do it in the next layer, it will not help, because files are already committed on one layer, previous layer. If we delete it on the next layer, it doesn't help at all in the size of image to keep them.
Thanks, Dima, Guillaume,
Yeah.
and so we can easily go beyond any limits with InterSystems Iris and Iris for Health images with this approach. And thanks to Guillaume, actually, I also included these techniques in the template I shared in the chat. So this is this Guillaume's approach is included, so you can leverage this template to build tiny images with Iris.
And basically what I see from the layer of Eduard, I'm doing exactly the same thing. Because I can tell with Eduard that you're copying the dat file at the end of the process without starting Iris. And that's basically what my script is doing, dynamically, in fact.
Yeah, unfortunately, Eduard, this is a very interesting topic, and we ran out of time. And I know that. Sorry, it's.
Evgeny, I lost
Sorry,
you.
some delivery at my home. Sorry. I just saying that it would be great if we could continue like speaking about deployment.
Yes, and we briefly discussed with Evgeny that we decided together not to break the conversation on this topic and start another one. So I'm sorry if we have some attendees who came for Python applications, deploying Python applications topic. But we will make sure to include that next time. Maybe we'll just host another roundtable dedicated more to Python and Python applications. And yeah, we can just continue speaking about this topic and move to offline and developer community. And if you're interested, just drop me a line saying I want another roundtable on this topic, and we can continue. We can just set up another one, like part 2. Okay. And also just a quick question: if you would love to, if you have something to present for the community that could be like useful for all the developers to know, just let me know, and we'll make sure to find a place for you, and bring you on stage, and you can share online what you got for other developers in our community and show. Okay.
Just real quickly, I put it in the chat, but the current versions of Iris appear to support both OS CPU and OS memory usage for the metrics API. So I don't know when it was added, but it is available. We shouldn't have to call out to the OS today. Thanks.
Oh, nice. Thank you, Ben.
Thanks, everyone. I will make sure to include all the links and all the files in a post roundtable article, and video will be also available. So yeah, keep in touch. Thanks, everyone. Have a great day.
Thanks, Olga.
Thanks, Eduard.
Thank you, guys.
Thank you.
Thanks, Olga.
Bye.